You said and the hold on, sorry. I just need to like catch up. So I just finished the FOIL part, so then that leaves you with 1 minus sine squared beta, and then that's over cosine squared beta. And then you said that reference sheet, that's where the one comes in.
Yeah,
Oh,
so you solve the top one. You move the cosine squared over, you get sine squared theta equals 1 minus cosine squared theta. The letter doesn't matter. So
sorry. So you said for like this first part, the sine squared, where does that, oh, and it plugs into this top part right here.
there's two ways to use it. Sorry, I'm not giving or cosine squared theta equals 1 minus sine squared theta. There's two ways to use the top one.
Oh, okay. Okay.
It's either that I mean you're either substituting it for sine squared theta and then it cancels, or you substitute the whole thing for cosine squared theta.
Can you just explain that one more time? Sorry, I'm just like having a hard time seeing it. So I get the identity is saying the sine squared theta plus cosine squared. So pretty much whenever
Right.
I see that, like when I'm doing the problem, do I just like rewrite it or?
It depends on the situation. Notice like in one case it's solved for sine squared, and the other it's solved for cosine squared.
Mm-hmm.
So it depends on how you see things. You can either fully replace 1 minus sine squared beta with cosine squared, which is what we did. Or
Oh, okay.
or you can just substitute in for, this will get more confusing here, or you can just substitute in for sine squared in here with the 1
Mm-hmm.
minus cosine squared, and then it simplifies to just cosine squared.
Oh, okay. So pretty much is it like with the Pythagorean identity, are you kind of like flipping it if that makes sense? Because for me it makes more sense to see like the sine squared and then like the sine squared and then to replace it with the cosine squared of
Up
B.
to you. It's up to you. This depends. I mean, more math you take, the more you get to choose how you sort of view it. I mean,
Okay. Okay.
they don't care as long as you get to the right answer.
Okay. Got it. Let me
How
just
you
write that
interpret
down
it.
then. 1 minus sine squared B over cosine that equals over cosine squared B, which is equal to 1. Theta plus cosine squared theta is equal to 1. Okay. And then sine squared. Sorry, I'm just copying it down the way that you have it just so that it like makes sense in my head and everything.
Yep. Good.
Which turns into 1 minus cosine squared theta. Okay, and the thing that you did on the bottom, was that just like a different way of viewing it?
Yeah, there's two
Because
ways to do it. Yeah, there's two
okay,
ways to do it. So you just have to choose.
okay, perfect. Let me go put that in then. Can you see my screen still or no?
It's not.
Okay, let me go back so that you can't see it.
Yeah, unfortunately, I don't know why. It's probably you can only one direction at a time. Well, for both participants.
Okay, this is the next one.
Okay. So let me grab this. So it's a sum and difference formula. You'll need those from the reference sheet. I'll also snip them in. So you'll need the one for sine, and that's on I guess it's page 2. Um, so here is that formula. So we're taking the numerator only, and we're expanding. So notice the top goes with the plus on top, minus the minus.
Uh-huh.
The top becomes sine. So just the top here becomes sine alpha cosine beta you're doing minus, so it's minus cosine alpha sine beta, and then you're dividing each, well, the whole thing's over sine alpha sine beta, like that.
Yeah.
That's the first split apart. Then you're dividing each of these by the sine alpha sine beta. It's not a
Sorry.
choice.
Can you just pause for a second? So the first part you said is sine theta times cosine of B, but where did you get that from?
Right down here, the sum and difference formulas.
Oh, okay. Okay. So that's just the formula then that you have on top.
Yep. It's the expansion of sine alpha minus beta.
Sine A times cosine B minus cosine A times sine B. Okay, and that's all over like the same denominator, sine A times sine B. Okay,
Yep.
okay, got it. I see where you're at.
And now you
Thank
got
you.
some cancellations. Those cancel, those cancel. So you're left with cosine over sine, which is cotangent beta. Cosine over sine, cotangent alpha. And those are just the reciprocal identities.
Got it. Let me just copy this down real quick. Just want to make sure that I have
Okay.
this.
Yep. Sounds good.
Cosine beta. Okay, and then you said that the sine A crosses out and that sine B
Yep.
crosses out.
If they're the same on the top and bottom, they cross out.
Okay, and that leaves you with cosine B minus cosine A.
You get it's cosine B over sine B. They're
Oh,
still
okay.
over each other.
Cosine B over sine B minus cosine A over sine A.
Yep.
And then you said from there it's just an identity property.
They're called reciprocal
Oh,
identities
okay.
or tangent and cotangent identities, depends on how you look at it.
Okay.
Um, they're also on that reference sheet on the second page. A lot of what you're doing is on the second page at this point in the
Got it.
course. So there they are. And there you have it. There's really no other way to do this problem unless you do it by hand.
Okay. Yeah, no, that's okay.
There's like even if you had a graphing calculator, you couldn't graph these because they're in two variables.
Minus
All right, so
cotangent
whenever you're ready, if
A.
you want to go ahead and share your screen again, we'll
Got it. Second one. Okay. This one I think is just calculator work. I think maybe. I don't know.
it could be, are you allowed to use a calculator in
I
your class?
can, but I have like a Casio, so it's not like a Desmo, so it's a little bit harder to use. But I
Right.
would like to learn how to do. If you can just like tell me, just to, I guess it shouldn't be too
Yeah.
hard in a calculator.
So the if as long as your mode is in degrees, you can get this. But the thing is this is not like a standard angle. That's the problem here. Like
Yeah.
you're thinking, oh, this is like square root of 3/2 or square root of 2/2. It's not. It's meant to be a double
Mm.
angle formula.
These
Like
are
it's
the.
go ahead.
Oh, sorry. I was gonna say, are these the ones where you have to like find two angles that like are on the unit circle and then add them up and then from there
Exactly.
you okay, yeah.
This is really now it's in the fourth quadrant. There's a couple ways to do it. Let's just do it the most direct way, which this is tangent 150 plus 135. That's the most direct way to do it. Those are both on the unit circle, and we're very happy with
Yeah.
those. So then you need the, and there's more than one way to do it, but this is just a way. Um,
Yeah,
so
no, it's okay. We can keep it this way because this is the way that I learned it in class. So I feel like this way will probably be is what I'll want to do when I see the test.
right. So then you're just labeling first one 150, the second one 135, A and B, and you're just putting them into the formula here.
Plus tangent 135 over 1 minus tangent of 150. So with these ones, you're not, oh, you are actually going to find like the tangent of these, right?
You do. And that's where,
Okay.
if you don't know your unit circle, that's where it's like, you don't know what to do. So tangent of 135 is the nice one. That's -1. Or
Mm-hmm.
we'll just put it down here. Tangent of 135 ends up being square root of 2 over 2 over minus square root of 2 over 2, which equals -1. That's the nice one.
Okay.
Tangent of 150 is 1/2 over negative square root of 3 over 2, which becomes 1 over negative square root of 3. And then you rationalize, multiply the top and bottom by the square root of 3, move
Okay.
the negative to the top. So it
Mm-hmm.
ends up being negative square root of 3 over 3. None of this should look like all that unfamiliar to you.
Yeah, no,
Like
no.
maybe you don't
So
like it, but
yeah, she lets us have like a little like note card on these exams, and on the note card I write like the unit circle, and then I write the tangent of each one right next to it. So that part will be super easy.
okay. So we're ready to put some numbers in. Tangent of 150 is minus square root of 3 over 3 plus -1 all over 1 minus square root of 3 over 3 times -1. That's just feeding these values back into
Mm-hmm.
the original there. And so this is the answer. It's just not what they want because it's not rationalized,
Yeah.
but it is an answer. So from here, it's just more algebra than anything. Like it's not difficult. It's just that is what it is. Um, this is 1 minus square root of 3 over 3. So what I would do first here is multiply the top and bottom by 3 to clear out the fraction in both.
Okay.
And then I would rationalize. Minus square root of 3 minus 3 over 3 minus square root of 3. And then you'd have to rationalize here. So you multiply top and bottom by 3 plus square root of 3, like that.
The square root of 3 divided by 3
And
times
I will be checking this
-1.
on a calculator because I know you gotta submit it for
Yeah.
grade, but like these are, these are the steps from here. So the bottom's the nice one. It becomes 9 minus 3, which is 6. The top though is a little messier. Minus 3 square root of 3, minus 3, minus 9, minus 3 square root of 3. So it becomes minus 12 minus 6 square root of 3 over 6. And then you divide each of those by the square root of 3, or by 2, by 6 to get minus 2 minus square root of 3. That actually does look correct, just having seen, a
Yeah.
lot of these over the years.
Sorry, can you go back up really quickly? Can you just go to the step of both, can you just show me like I just went to the multiplication again? Because I just tried punching it into my calculator. And it was a little bit different, so it's not gonna work the way I wanted to. So you said what you did first was you multiplied it all by 3.
You cannot use your calculator on this. There's no, unless you got like a PI Inspire, that's,
Oh, okay.
the calculator will not help. All by hand.
So you multiplied it by 3 was the first step, and then after you multiplied it by 3, that's when you got to
It's black.
this area. Okay.
Yeah.
Can you just explain that again? Because I'm just confused how you got those from multiplying it from the 3.
Okay. So I'll do that and I guess I'll do it in green off to the side here. Minus 3 square root of 3 over 3 plus -3 over 1. 3 minus 3 square root of 3 over 3. So going
Oh, okay. So with
this
the
way.
3, you just threw it in front of like the.
Yeah, it does not go
Oh, okay,
inside the root.
okay.
It can't,
Oh, okay.
not allowed.
Sorry. Let me just
Do
write
not,
that down then,
do,
because that's what I was
yeah, do
confused
not path
about.
go. Yeah, it's
-3 square root of 3 over 3 plus -3 over 1. That's all over. Okay. And then when you got to that step, is that when how you got down to the black?
yeah. Yeah.
Mm, can you just explain how you got to the black again? Sorry.
You gotta ask me some questions. Like this is like you gotta tell me what you don't follow because it's like this one in green here goes with this one here. Top
Yeah,
left goes top.
can you just show like how you got to each one like individually? I understand the -3 over 1 because that's just -3, but
Yeah,
this like the one that's like
yeah.
rationalized or the fractions.
3 divided by 3 is 1, so you don't write anything. You just
Oh,
you write
okay,
right
okay,
here.
okay.
And just bring the 3 down. And then same thing here, you're dividing.
And that brings me to negative square root of 3 plus or minus -3. Yeah. Mm-mm-mm. Okay, and then from here you multiplied by the.
Conjugate.
Okay.
Which is just a change in the middle operator right here.
Mm-hmm.
That's the conjugate. It
Okay.
always rationalizes the bottom, which is why it becomes 6. Uh, it's a FOIL. I mean, and then you're just foiling the top and the bottom.
-3 square root of 3 -3 -9 -3 square root of 3 over 9 -3, which is equal to 6. And you said that for your final answer, you was it 2 square root of 3 -3? Or, okay, -2.
That
-2 minus
that is
3
that is
three.
confirmed by the online calculator.
Got it. -2. Okay. Okay. This one, pretty similar.
Yep. Just got a snip of it. Okay, so you again need the sum and difference formulas to be able to answer this. No other way to do it reasonably. And so this one's cosine now. Uh, you always want to pay attention to the formulas. I know you're gonna have them on your reference sheet, but this one, the top plus, which is what you have here, it goes with the
Mm-hmm.
top minus.
Okay.
Um, so that this is A, this is B. So it becomes cosine 240, cosine 45 minus sine 240, sine 45.
So sine 45 minus sine 240 times sine 45. Okay.
And so then
And
you're
these
going,
ones, you just multiply them, right?
yeah, we'll do that now. I mean, and so you're gonna have unit circles, so we'll just look these up. This is -1/2. Cosine 45 is root 2 over 2. Sine 240 is square root of negative square root of 3 over 2. and sine 45 is square root of 2 over 2. They should always have the same denominator, matching
Okay.
denominators. You shouldn't have to like do anything with them. So this becomes minus square root of 2 over 4 plus square root of 6 over 4. And then you combine the denominator, sorry for the scrolling,
You're
minus
fine.
square root of 2 plus square root of 6 over 4.
Okay. And you said that the oh okay, that's why I forgot the minus. Never mind. Minus square root of 2 plus square root of 6 over 4.
Let me just check this one also on the
Mm-hmm.
calculator. Cosine 285. Square root of 6. Yeah, looks good. That's a negative there. That's not
Got
clear.
it.
It's a negative.
Okay, let me share my screen. Okay.
Let me go ahead and grab. Yep. Okay, so we got triangle in quadrant 4. That's
Mm-hmm.
this one. And if you remember, there's 4 reference triangles that you could have depending on the quadrant.
Yeah.
Excuse me. You'll have to remember those. And sine of A is minus 7 over 25.
Mm-hmm.
And you have to find the third side. So finding the third side is always with Pythagorean theorem.
Okay.
Uh, let me know if you need me to clarify this. It is 24. I don't know if you want me to go through that or not.
Yeah, could you?
Sure. So we're gonna call we're gonna label the sides here. So A and B are always the legs, C is always the hypotenuse.
Mm-hmm.
So in this problem, we're saying A squared plus negative 7 squared in parentheses equals 25 squared. A squared plus 49 equals 625. When you subtract, you get 576. And then we take the square root of both sides, you get plus or minus 24. Since you're going to the right, we know it's positive.
Okay. Sorry, let me just copy that down. That was kind of fast. Just give me a second.
Of course, you've done this before though, so don't
Yeah.
overthink it.
A squared plus 49 is equal to 625 and then minus 49. 576 square root A is equal to. And with this part, how do you know to choose? Oh, if it says if it's a sign, right? That's when you know to choose positive or negative.
It depends on where you are in the quadrant system. Like if you're going to the right, like what's your co-terminal point is here in the fourth
Mm-hmm.
quadrant. So to get there, you're going right. Whenever you go right, that's positive, down is negative.
Okay.
It's more to do with where you are in the coordinate system.
Okay. Positive
Like
sign.
if you were to go left, it would be negative. If
Okay.
you were to
And
go
you're basing
down,
this off of where it says like quadrant 4, like in front, right?
well, that tells you which triangle to draw and where the
Oh,
reference
okay.
angle is. But like quadrant 3 is this one.
Mm-hmm.
And so cosine of beta is minus 3 over 5. It's
Okay,
on
because
it.
you're moving to the left.
Yeah. Well,
Okay.
so now the value, whatever we get up here is going to be negative, ends up being -4. Negative because you're going to the left.
Okay. Okay, cool. Got it.
All right, so now we're back to sine A plus B. Sine A plus B here. You have to use the sum and difference formula
Mm-hmm.
for that. And like at first they seem really difficult to memorize, and I would still write them down, but you'll notice, you know, you do a couple of them, you're like, oh, they're actually like there's a pattern to them. It's not
Yeah.
as bad as you think. So, um, yeah, this is what you're doing. You're doing plus. So you're gonna have sine A cosine B plus cosine A sine B. So
So,
you go back to whichever triangle you need. So you need sine of A. Sine of A. You're looking at the triangle on
mm-hmm.
the left here. That's -7/25. Then you need cosine of B. Cosine of B is -4/5. That's this triangle on the right. Plus you
Okay.
go back to the one on the left for the cosine of A. That ends up being 24/25. And then you need the sine of B, which is -3/5.
24/25 times -3/5. So how,
The bottom,
just really quick,
bottom.
oh, sorry. So like
No,
in
go.
our class, so is there like a way to memorize, like how did you know that it was like 7/24? Because doesn't that have to do with like the cosine and sine and all of that, or like the
Yep,
SOHCAHTOA?
yep, that's exactly it. So you're responsible for knowing these, meaning like, and this was learned earlier in the course. Sine
Mm-hmm.
is opposite of hypotenuse, adjacent over hypotenuse, and so on.
Oh, okay, okay. And
That's
that's
where
how
they
you
come
got
from.
the sine, and that's how you got like the cosine
Yes.
adjacent over hypotenuse. Okay, got
So
it.
it
And
really is a
then
synthesis of everything you've been learning.
okay, and then also for like the second triangle, I know we used it, but like why did you throw that one in? Oh, because it says with the third quadrant, right?
Yeah. And you got to get the one over here in the third quadrant.
Okay. Okay, that makes sense. Okay.
All right. It makes more sense to do this than to draw it like the same orientation and have to mess with signs.
Yeah.
Like, oh, I'm going left and down, so from the origin, so I know those are negative. So like the previous problem, the bottom always matches.
Mm-hmm.
So you should never have to make like a common denominator. That would be weird. Um, this ends up being minus publish 44/125.
Let me see. Hold on, I'm putting it into my calculator right now. -72/125. I think that's right. So it's just 28 minus 72? Yeah. Yeah, it's -44.
Okay,
-44/125. And then that's like my final answer, right?
that's it. Yeah, after all that.
All right, cool. Ugh, program is so picky. Oh, it said the answer was -3/5.
Oh yeah, so I put these in the wrong spot. These were flipped, so that will do it.
Oh, okay.
That'll affect everything down here.
Quadrant 4, quadrant 3.
So do you want us to redo it, or do you have another one for us to work
No,
on?
it's okay. It's fine. I get the idea of it. Let me just get the next one.
Go ahead and share your screen whenever you're ready.
Hmm. Okay. This one just says to simplify, but I don't know.
Yeah, this one is, I mean, you're sort of out of trig at this point. Let me
Yeah,
finish.
sometimes it'll give me like refresher questions, but I can't like skip them. So,
Right, so you have to factor both the top and the bottom. In
hmm
both cases, you're looking for two numbers that multiply to the last. So, so if we look at the top here, multiplies to -5, but adds to 4. So that becomes x plus 5, x minus 1. So 5 and -1, they multiply to -5, but they add to 4.
hmm
In the bottom, you're looking for multiplies to -30, but adds to -1.
but add to. You said multiply. Sorry, I'm just copying this down.
It multiplies to the last, but adds to the middle.
Okay, multiplies to the last, but adds to the middle.
So
So that would be
5 and
like, oh, okay, got it.
5 and -6, they multiply to -30, and then they add to -1.
All right, and then you just the x plus five can cancel out, right? And then you just up with
That's right.
x plus one over x minus six.
And that's sort of the hint or the help, the cheat that the one should cancel the way it's
Okay.
written. So, if you're unsure, you can, guess one of the ones that's there.
Okay, let me share my screen. Okay, this one's just another sum and difference.
That's right. It's a little harder. Sometimes for students that you haven't seen, if you're not comfortable with radian, you might convert the answer to degrees
Mm-hmm.
to kind of get a feel for like, oh, what is it? What angle measures it? Because 5 pi over 12, it's like, what is that? Uh, you'll know you typically use some variation on pi over 3, pi over 4,
Yeah,
pi over
with
2. So
these
like,
ones, oh, sorry, these ones you can add them up to get to like 5 pi over 12, right? That's how you do these?
right. So this one's really
Okay.
pi over 3, or sorry, pi over 6 is really this. Pi over 4 is 3 pi over 12, and pi over 6, I'm sorry, pi over 3 is really 4 pi over 12. So you can see how I just combine these two to
Mm-hmm.
get 5 pi over 12, which means
Yeah.
it's really pi over 6 plus pi over 4 that you're adding together. So once you get those, okay, you use the sum and difference formula. Now, like if this were a legitimate test question and you didn't have to show any work, you could just calculate the value and then compare to the given values. You could put them in the calculator, but
Mm-hmm.
you got to show work like we're doing here. We'll call A pi over 6 and
Okay.
B, so it becomes sine pi over 6 cosine pi over 4 plus cosine pi over 6 sine pi over 4, like that.
Cosine pi over, oh, cosine pi over 6 and sine pi over 4. And then you just find the values for those, right?
Yep.
Sine.
So pi over 6, you got 1/2 times √2 over 2 plus square root of 3 over 2 times √2 over 2.
Cosine
So
of
you end up
pi over
getting
4.
square root of 2 plus square root of 6 over 4.
Okay. Square root of 2 plus 6. Okay. Perfect. Okay, and this one I assume you started the same way, right? Even if it's tangent, you just find something that would add up to them.
Yeah. um, so let me grab a snip here. All right. And so when you let's say this, if you're looking at the unit circle,
Mm-hmm.
that's where you're sort of making your guess, like, well, what is it? Which one is it? So this
Yeah.
one ends up being 8 pi over 12.
Mm-hmm.
And the next one here is 9 pi over 12. And then this one is 10 pi over 12. So like, okay, I got to use one of those. Well, which one are you gonna pair it with? This is 2 pi over 12. This is 3 pi over 12. This is 4 pi over 12. So you can either go you can either go 8 pi over 12
Mm-hmm.
plus 3 pi over 12, or you can do 9 pi over 12 plus 2 pi over 12.
Okay. Mm, we can do the 8 pi over 12.
Okay. So that's 2 pi over 3 and 4 pi over 4. And that's your A and your B. So you get the formula for it. And then you write out the formula with the numbers. Let's do that.
Pi over 3 and
So you've got tangent 2 pi over 3 plus tangent pi over 4, 1 minus tangent 2 pi over 3, tangent pi over 4.
pi over 4. Sorry, I'm just following along.
Yeah.
So
Let me
tangent
know when you get caught
of
up here.
2 pi over 3 plus tangent pi over 4. And that's all over 1 minus tangent 2 pi over 3 times tangent pi over 4. Okay, so then tangent for 2 pi over 3 would be equal to negative square root of 3 plus tangent of pi over 4 is 1. That's over 1 minus tangent of 2 pi over 3 again is negative square root of 3 times tangent of pi over 4 is 1. Okay. And then from that point, it's just a matter of just like adding them and just combining them.
Yeah, I mean, there's a whole lot of work, but yeah, it's so it ends up being, I mean, it's not terrible. It's minus square root of 3 plus 1 over 1 plus the square root of 3, which you end up having to rationalize.
Hold on. Sorry, I just wrote it differently, but I think it's the same one. So that turns into 1. Oh, yeah. Plus the square root of 3. Okay. 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 I see what you're going.
And so after we do this, I mean, I'll definitely check it out, get the full answer here
Mm-hmm.
on the computer. But on the bottom, it becomes 1 minus square root of 3 plus square root of 3 minus the square root of 9, which ends up being 1 minus the square root of 9, which is 1 minus 3, ends up being negative 2 on the bottom.
Mm-hmm.
And then the top, similarly, you got a FOIL here, minus square root of 3 plus square root of 9 plus 1 minus square root of 3. So you end up getting, this ends up being 3. You get 4 minus 2 square root of 3.
Mm-hmm.
And you have 4 over negative 2 minus 2 square root of 3 over negative 2. Negative 2 plus the square root of 3. And I'll just double check that. We were doing tangent. of 11 pi over 12.
Tangent of 11. Okay. Did it match up?
Yeah, it's good.
Okay, cool. And you said that when you got to the 4 over,
-2.
yeah, okay, so on the top part, like right above your mouse, like the 4 minus the square root of 2, I mean 4 minus 2 square root of 3. So you just split that up into the -2, like over both of them.
You're dividing both by -2. That's what we.
Oh, okay. So it wouldn't just be one because like are they separate then?
No, it's not a choice. They both get the -2.
Okay, okay, cool, cool. Alrighty. All right. -2 plus square root 3. Okay. Let me share my screen.
Could you just move your cursor over slightly?
Oh yeah, sorry.
There we go. All right, so this will go pretty quickly. Okay, so the one of the very first strategies, again, we talked about earlier, is to foil, just to foil
Mm-hmm.
this, what's here. But yeah, that's what you would think to do. But whenever you see something squared, you want to think Pythagorean identity.
Okay.
Okay, and those were we looked at those earlier today. Let me grab another snip of those. It's nice in the notes to have them right there instead of wondering where are they. So, all right. So, for example, this first one, we know that sine squared theta becomes 1 minus cosine squared theta, or or vice versa.
Yeah.
So this first 1 minus cosine squared theta, that
Mm-hmm.
becomes sine squared theta. So this right here becomes that.
Sine squared theta. Okay.
And then this last one here, if you subtract 1 from both sides, you get cotangent squared theta equals cosecant squared theta minus 1. So this second one here becomes cotangent squared theta.
Okay. Times
Then you bring the
cotangent squared
secant theta
theta.
down. So let me know when you get caught up to that.
Okay, and that's just times secant theta?
Yes.
Okay.
Okay. Are you caught up to there?
Mm-hmm.
Okay, I'm just gonna come down a little bit further because we're running out of room here. So you break apart here. So sine squared theta, and then cotangent is cosine squared theta over sine squared theta.
Cosine squared theta over sine squared theta.
Yeah.
Okay.
And is that and so those cancel. And then secant is 1 over cosine theta. So one of that
Mm-hmm.
cosine theta cancels one of those, leaving just cosine theta there.
Okay. And why did you so you said you did sine squared theta times cosine squared over sine squared. Is that from like the formula or is that just like how did you
Yeah,
get to that point?
cotangent's a reciprocal identity, so you
Oh,
have
okay,
to
okay.
remember that. One of the strategies is to always convert everything into sine and cosine, which is what we
Okay.
did in the last step here.
Okay.
All right. We'll take a look at the next one. If it's really short, I'll run through it real fast. If
Okay,
not,
perfect.
see.
Let me see what that and you said for this one, oh yeah, it was cosine of theta. Cotangent of theta. Oh, this one's easy. This one is just asking for cotangent of theta and it gives me a triangle. So I'm okay with this one.
All right, well then we will stop here for today.